Hi gents, we're going to have a look at this 2017 paper 2 question 1 just to give you the answers there. I was asking you just to try it yourself. So here you go. So what do we have? Write A, B, C and D into the appropriate places in the table. So we've got our first shape, which is here, and it's just asking you what's what. So let's look at axial symmetry. So if you have axial symmetry, that's symmetry through a straight line. Now it could be any straight line, so it's not clear which one it is. I'll just change color here. What happens if we say that this is the line? Well, where would this point go? That point's already on the line, so it would stay there. This point here, let's just zoom in on this. This point here would go through the line and back out the same distance direction, and it would end up there. This point would end up going straight through the line and end up there. Perfect. This one here goes all the way through the line, same distance and direction, and ends up there. So you can see here we are dealing with axial symmetry. So for that one, I would want to be saying that B is axial symmetry. Okay, that the original shape goes to B when you do that. Okay, I see there's one that says central symmetry in 0, 0. That is to say, every single point goes through the origin and back out the same distance and direction. So again, if we do our little zoom in here, this point is going to go through the origin and back out the same distance and direction. Again, we can already tell it's D, but let's just fill in the other ones while we're at it. Straight through the origin, back out the same distance and direction, and it ends up there. This point here, straight through the origin, back out the same distance and direction, roughly there, and so it is with the last one. This point here, through the origin, so it's actually going straight along the x-axis, and it ends up there. So if we want to do central symmetry, the original shape is going to end up going to D. It's going to end up going to D. Okay, rotation about the origin. So in this case, it's kind of hard for me to explain this since I'm not on screen. So it's kind of up to you to figure out what we mean by rotation of rotation through 0, 0. It would mean, for instance, if we were to take, it might not be a bad idea to take this point here. Okay, if we were to rotate that 90 degrees, it would mean that instead of moving over 3 and up 1, what you would actually be doing is you'd be moving over 1 and up 3. So that there, if we would take that, that would then be a rotation of 90 degrees. Okay, and so it is actually with all the rest of them. Moving over 1 and up 1 means the same as moving over 1 but in the opposite direction and up 1. That's what we would have here. This one here, moving over 2 and up 3, means moving over 3 and up 2. So that ends up there. Basically, what we have here, the original shape, when you rotate it around 0, 0, you are going to end up with the image C. And finally, translation, which I don't actually think I mentioned in the other one, so I probably should now. I'll take the time. If you've got a letter, for instance, F, and you want to do a translation, that just means you pick it up and you put it somewhere else. That would be the image of F over there. You could bring it there. It doesn't rotate it, it simply picks it up and places it where it was. So it doesn't rotate or anything like that. And I think that if we look at that, clearly the image A there has just been, the original shape was just taken and placed over there. There was no rotation movement other than picked up and placed. So we would say A there. It is of course the final one in the puzzle, so it would have been, easy to guess, but it's also worth knowing why that is the case. Okay, so that is a great little way just to practice that you know the transformations and that you understand what they are. Hopefully those are the answers that you got as well. Okay, gents, give it a correction. If there's any trouble, just drop me a line, as many of you have been doing, so I appreciate that. Thanks, guys.